Welcome back. So we'll start the session from where we left in the last one. So we're discussing about general indexings, and in that regard, I have already told you about SCI, Scopus, and all that. So let us know about all this indexing in a little more detail. So what happens in the what is basically the SCI, or SCIE, SSCI, or ASCI? So as I told, the full form of them are SCI stands for Science Citizen Index. SCIE stands for Science Citizen Index Expanded. SSCI stands for Social Science Citation Index, and AHCI stands for Arts and Humanities Citation Index. So all these citation indexes uh, are now managed by an organization called the Clarivate Analytics, based in US, and since 2018, there has been some changes in these databases, and now no longer the organization that is the Clarivate Analytics, it publishes a separate SCI list. It doesn't publish a separate SCI list. Now we have only one list among the SCI and SCI, and that is called the SCIE. Okay, we do not have a separate SCI list until like 2018 that we had. Now we do not have a separate SCI list, but we have some separate three separate lists for SCIE, SSCI, and AHCI. So as I told, all of these are considered to be the most prestigious in their respective fields. Okay? Since SCIE is for science and engineering, SSCI is for social sciences, and AHCI is for the arts and humanities. Now let us go to the website and see what additional information we can get on the website and how you can get some more meaningful information from this particular website. Now, as soon as you go to this website, this is the new website for the SCIE database, and that is managed by now the Clarivate Analytics. And now here, what we'll do is that we'll go and create a login. So if you already do not have a free account, you can create a free account either by using your Facebook, or by using Google, or by using LinkedIn, or by using Orchid. Okay, or maybe you can even register here if you have some other email IDs. Now, since I've already registered here, so I'm just going to log in with my Gmail. So I'll just go and log in with my Gmail, and I'll just go on and log in with my Gmail. So as soon as I log in, so yeah, let me show you. So as soon as I log in, this is the particular website, and here your name would be displayed, and you have some settings here. In the settings, you can make some adjustments, how you want your profile to appear and all that. All these kind of things you can do here. Okay, and basically you have to understand that this is a free version, so you can have multiple accounts which can be added here. So I have added all my email IDs which I generally list in my papers. I've listed it here so that it can automatically track my different papers, and you can even connect different accounts here, and if you want, at any point of time, you can delete this account. Now let me return to the Web of Science master list, and here I should tell you that the Web of Science is basically an amalgamation of all these indexings that I have already mentioned, and apart from this, there are so many other indexings also. For example, I've already mentioned about the SCIE, AHCI, and SSCI, and other than that also we have a lot of other small kind of indexings like the biological abstract, biosis previews, and so on. We have so many other kinds of small indexings. Okay, these are like some subcategories, some very specific categories. Okay. Now, how do we use this particular website? So the first thing we can use it for is for finding out whether a particular journal is listed in the SCIE database or in the Web of Science database or not. So we can use it for that particular purpose. So this is the first purpose that we can use it for. So let me just go and type in the name of a journal. Okay. Suppose say I am worried about, or I want to find out whether this particular journal called the Engineering Computations is in the SCI database or not. So I'll just type in the name, and I can go in and do a search. Now, depending on what you have searched, you will get some exact matches and you will get some approximate matches. So you can see that I have a blue border shown here, and here it is showing that I have an exact match of the name, and these are some approximate matches. Okay? All these things that you see here, They're all approximate matches. In fact, by using both of these names as combinations, I have around 3,278 items that are listed here. And out of this, uh, I'm only interested in this one because I know this is the journal that I'm looking for. It is published by Emerald Group Publishing. Okay. So the next thing that I'll do is that I want to have some more information on this particular journal. Okay. So if you want some more information, the first thing that I can to see here is that in which core collection is it included. So it is included in the SCIE, that is the Science Citation Index Expanded. It is included in this particular database. If I want some more information on this, I can just click on here on the view profile page, and here I'll get some more information regarding like the cover page of the uh, particular journal. I will get the uh, address of the publisher, the ISSN, and so on. I'll also get some information regarding when was it first published and how many issues it published in a year, and what is this frequency, and all this kind of information. I will get it here. In fact, I will also get some information regarding the impact factor of this particular journal. Okay, so let me show you this one by one. Here it shows you in which particular Web of Science core collection it is there. So what are the core collection? Web of Science core collection are only three. We have only three core collection, that is the SCIE, AHCI, and SSCI. Okay, so from now on, I will be using the word Web of Science core collection to mention all these three, and I will be using the word Web of Science for referring about the other indexings like this, the current content and engineering science indicators and all that, essential science indicators. In fact, there is another indexing called the ESCI, that is the Emerging Sources Citation Index, that also comes under the additional Web of Science indexes. Okay, so I'll be using the word core collection to mean only the three primary indexings or the three most prestigious indexings, and I'll be using the word Web of Science for the other kind of indexings. So in the core collections, so this particular journal is involved, or this particular journal is covered in the core collections. And now if you scroll down, you have some more information here regarding 2019 and 2018. So in the uh, journal impact factor, you get the importance about what is the uh, what is the uh, impact factor of that particular journal. You see that this journal has an impact factor of 1.246. Okay, and here you can have the journal citation report. Here the journal citation report is there. From the journal citation report, you can get more information. And here you get the information regarding Publons. Publons is again a subsidiary business of the Clarivate Analytics. We'll talk about Publons also in a bit. So let's not talk about this now, but you get the information regarding Publons also here. So let me just click in view citation reports and let us see what information do we get. A lot of information, yes. So it seems that you need a separate login to have access to the journal citation reports. So the journal citation reports is a yearly or an annual report that is published by the Clarivate Analytics, which contains the information about all the journals which are listed in the Web of Science core collection. Okay? Since I do not have a subscription for this particular Clarivate Analytics, so I cannot log in there. But maybe if you have some subscription for this, you can log in. Generally, your universities may have the subscription, and through that you may log in there. So this is the first use of the Web of Science data Web of Science website that you can use it for. There are again some other important or some other additional task for which you can use the Web of Science website, but this is one of those tasks. We'll see about the other tasks when we come about it. But right now, let's not bother about that. Let us return to our PPT. In the PPT, we have a different type of indexing called the Scopus indexing. This is generally considered to be the second most prestigious indexing after the Web of Science core collection. Okay, the Web of Science core collection is considered to be the most prestigious, and after that, people rely on Scopus all over the globe. So now we'll also look at the Scopus database. The Scopus database is maintained by the publisher called Elsevier. It is a subsidiary business of the Elsevier. So if you remember, I already told that Web of Science is maintained by Clarivate Analytics, and Scopus is maintained by Scopus is maintained by Elsevier. So here it seems I've already logged in. Similarly, if you do not have an account, you can create a free account, okay, by using the your Gmail ID or maybe your LinkedIn and all that. So I've already created in and already logged in. So as soon as you come to this website, you will come across this particular website. So here I will go and click on the sources. I want to see whether a particular journal is indexed here or not. So I'm going to go and I'm going to type in the name of the journal that I know. Okay, engineering computations. Now, as soon as I do that, here also I see some information here. I see the information regarding the journal. I can go and click on here. So here it will show me a lot of information regarding the Scopus coverage of this particular journal. So it says that in Scopus it has been covered from 1984 to present, and it is published by Emerald. All this kind of information you get it here. Here you get the information regarding what is the site score of this particular journal. Again, site score is something similar to the impact factor that the uh, Web of Science publishes. So the Web of Science publishes the impact factor, and similarly, Scopus publishes the site score. Okay, so you see that it has a very healthy site score of 2.1, and then we'll go on to see the other information that is listed here. So you can find a lot of other information here. For example, if you want to look at the site score of 2018, you can just change it, and you can see that it is around the same. It is around 2.2 in 2018. Similarly, in 2017, if you want to make some kind of a study, you can see that it is around 1.8. Okay, now we can go on and 67 percentile. When we talk about engineering and computer science, it is in 44th percentile and all that. So basically it tells you the standing of the journal within the SCI database, or sorry, within the Scopus database. And if you go to the site score and trend, here you get some additional information regarding the last 5 years performance of this particular journal. Okay, this is sometimes very relevant for you to analyze, so that you know that this particular journal is going to perform well in the upcoming years also. Because again, since you have already published in since you publish in this particular journal, now your reputation is now linked with the reputation of the journal. If suppose say the reputation of the journal in which you have published is not good, then people will think that your paper was not that worthy. But if suppose say you are able to publish in journals like Nature or suppose Science or in acclaimed journals, then people will think that your the perception is that your research is very excellent. That is why you have been able to publish in those kind of journals. Okay, let me go and change it to 2019. I'm interested in 2019 data. Okay. So yeah, so here you see that it is in the 66 percentile. It means it is somewhere in the Q2, Q3. Okay, it will be in the Q2. Okay, it will be in the Q2 quartile 2. Okay, so we have the information regarding the last 5 years of its performance in terms of site score. So you see that it is maintaining somewhere around 1.9 in site score, and here you find all this information, and you can go on to the next one where it shows the content coverage. So you can see that in 2019, 202 documents were covered by Scopus. In 2020, so far 117 documents have been covered, and so on. So this kind of information you can get it from the Scopus database. Now, how to find out whether a particular journal is indexed in the Scopus or not? So for that, you can go and do this search that I showed. You can type in the name and see whether it is still there in the database or not. Conversely, what you can do is that you can go and download the list from here. If you can see my mouse, here in the mouse cursor, you can see that this is the Scopus list, source list. If you just click here, it will be downloaded. Since I already have them, I'm not clicking here and not downloading here. Similarly, you can look at the book list which are covered in the Scopus database. Similarly, you can look at the Scopus discontinued source list also, that which journals are now not covered in the Scopus database. Similarly, we have something called the Medline for the medical sciences. So Medline is another database which stands for Medical Literature Analysis and Retrieval System Online. Okay, it is another bibliographic database which is maintained by US National Library of Medicine, and it is considered very reputed for the people who are in the health sciences. Okay. Again, PubMed, which is a free search engine for the Medline, can be used for searching the Medline. We also have something called the Google Scholar. Again, all of you probably have already heard about Google Scholar. Google Scholar by far is the largest uh, database or the largest scholarly public article database out there. So Google Scholar is, as you can understand from the name itself, is a subsidiary of the Google, in fact, of the Alphabet Inc. Okay. So probably you do not know this, that Google Scholar is headed by an Indian researcher from IIT Kharagpur, who now is associated with Google. He's called Anurag Acharya. So he was the one who came up with the idea of Google Scholar, and since then, since 2004, he has been heading the project of the Google Scholar. Google Scholar contains around 389 million documents until as per the latest estimates in January 2018. Though Google has never revealed the exact number of documents that it covers, but most people now uh, claim that somewhere around 430 plus 430 million plus documents are included in the Google Scholar database. Again, here I should make another important distinction between the Google Scholar and the other databases is that the other databases that you saw, for example, the Medline or the Scopus or the SCI or the Web of Science or the PSCI and so on, all these databases are in these databases. What happens is that a particular journal is indexed or not indexed depending on the quality. But Google Scholar is the only database, perhaps the only database where we do not have any distinction. We do not have any, in that sense, I could say that there is no discrimination among the articles in terms of quality, because anything that is available on the internet, and if Google Scholar can find it, it will be indexed in the. So in that sense, you can say that Google Scholar is not a proper indexing, because one of the properties of the indexing is that one of the properties of the indexing is that there should be some quality check. In Google Scholar, there is no quality check. Anything that is available on the internet in terms of scholarly publication is available in the Google Scholar. So in real sense, Google Scholar is a database rather than a indexing, right? So again, we can go on to the Google Scholar. You can just click on here. Seems something has happened to my. I'm not sure why it is not. I'm not able to click it. Yeah, I think the hyperlink is not working. So let me go and show you here. So if you want to go on to the Google Scholar, you can just go on and click here. So this is basically the Google Scholar. So here you cannot search as per the journals. For example, if I go on and type here, give you a lot of erroneous results, because what is happening is that it is showing you papers which have the word engineering computation. So by default, in the Google Scholar, you cannot see which journals are there. Rather, you can use it as a search engine for finding out the different kinds of papers. For example, let's suppose say I want to find out a paper on composites. On composites along with and I can just go on and click on this, and depending on this, it will show me all the papers that are there in this particular topic, and it will show me the different journals in which these are published. So it shows when you search here, it shows you at a article level database. It shows you some article level information. Now we have something called the citation index. What is basically a citation? Whenever you list a particular paper in your reference, basically what you are doing is that you are acknowledging the fact that this particular paper has helped you in some way or helped your research in some way, and that is why you are kind of giving a credit to that particular paper by citing it in your reference. So when you do that, the citation count or the uh, referring count of this particular paper goes up by 1. Okay, so it means every time you cite a particular paper, okay, it gets, or every time you refer to a particular paper in one of your research papers and it is published, the paper which you have referred gets one citation. Okay? So like this, the citations are counted. For example, if a paper is referred to 10 times by 10 different papers, then the citation of that particular paper will be 10. If suppose say a particular paper is referred 20 times by 20 different published articles, then its citation will be 20. Now, why this citation is important? Because citation tells us, and citation is a kind of a measurement about whether a particular paper is relevant or whether a particular paper has been helpful to the scientific community or not. For example, if suppose say I write a paper, I am going to cite only the papers which are relevant to my work. So in a sense, those papers that I am citing in my reference are has helped me improve my research or help me gain some kind of uh, information on my research, and that is why I am giving a kind of credit to this particular papers by referring them in my reference section. So that is why it simply means, in other words, we can say that if a particular paper has more number of citations, means more number of paper has found it useful, and more number of paper have referred to it in their own reference, right? So in that sense, we can say that citation is a measurement of the uh, utility of a particular paper. But because there is no other means to measure the uh, quality of a particular researcher or quality of a particular journal, citations have been also thought of as a metric for quality as well as uh, usability, right? Though it is only a only one feature of the uses, but still people consider citations to be the most reliable data when we talk about the credibility of a journal. So in other words, what I'm trying to say is that whenever a particular journal is referred to more number of times, it means more and more people have found that particular journal helpful, right? If we talk about the article point of view, if more number of people have referred to a particular article, it means more people have found that particular article relevant, and that is why they have cited. Similarly, when we talk about one step higher in terms of the uh, journal itself, if more number of people have referred to the papers from that journal, it means that particular journal produces very relevant work to the scientific community, and that is why it is getting more citation. So using this particular logic as the criteria, a lot of citation indexes have come in. So citation indexes are nothing but some kind of quality metric. Okay? So the first among them is impact factor, which you already saw in the Web of Science database. In the impact factor, what happens is that the formula for impact factor is listed out here. So the citations in a particular, if suppose say I want to calculate the citations of 2019, if suppose say I want to calculate the impact factor of 2019, what I will do is that I will find out the citations for that particular journal in 2019 and 2018 and divide by them by publications in 2017 and by 18 and 19. Okay, and in this way I will find out the impact factor of 2020. So you can see the formula here. Here we have shown the formula for impact factor of 2017. So we take the citations of 2016 and 15 and divide it by the number of publications in 15 and 16 and so on. We have the impact factor. Okay, and again this impact factor is managed by the Clarivate Analytics. We again have something called the site score, which we saw in the website of the Scopus. And the site score is again a contemporary metric to the impact factor, and the site score is calculated by Elsevier. It was launched in 2016, and in this year, in 2020, the formula has been revised. Until very recently, it was considering 3 years data, but from this year, 4 years data has been considered for the. Basically, how it works is that if you want to find out the the site score of 2015, then the data regarding the number of citations in 2014, 13, 12, and 11 will be considered here, as you can see on the formula, and we will divide it by the total number of the publications in these 4 years. Okay, so this is how we calculate the site score. Next, if we compare the impact factor and the site score, so generally we have, I should change this. because, sorry, I'm not sure what happened here. So sorry about that. So as I told, the formula has changed very recently, means in 2020 in June. Okay, again, another important thing that you should know is that every year the impact factor and the site score data is published in the month of June, July. Okay, so only like 1 week back we had the new formula for site score. So the new formula for site score has said that the evaluation period is for 4 years, whereas in impact factor it is for 2 years, and impact factor is calculated from the JCR, that is the Journal Citation Reports managed by the Clever Analytics, and site score is calculated from the data obtained from Scopus managed by the Elsevier. In JCR, we have roughly somewhere around 12,000 journals, whereas in site score or in Scopus, we have somewhere around 38,000 items in terms of both books as well as books as well as periodicals as well as journals. Again, we'll go on to the other citation indexes. There are some other citation indexes called the SNIP. These are not so relevant. If you want to know more about them, maybe you can we can ask a question. Again, all the information is already there in the PPT. If you want to know any additional question, maybe you can pose a question for the question answer session, and we'll be happy to answer that. So, source normalized impact factor (SNIP) is another citation index or another quality metric given by Elsevier by the Scopus database. Similarly, SCI journal rank or the SCI Mago journal rank or the SJR is another quality metric that is given by the Scopus database. Similarly, we have a index called the H index. H index is also a quality metric for which is given by Scopus or Google Scholar, and this particular indexing or this particular sorry, not indexing, this particular H index or this particular quality metric is applicable both for journals or for the authors. Okay, initially it was started as a author level metric, so where we tried to analyze the number of where we tried to analyze the productivity of the researchers. So what basically H index is, that H index uh, is the number of publications that have the same number of uh, uh, indexings, that have the same number of citations. For example, if I say that my H index is 15, so it means I have published at least 15 papers, and each of these 15 papers have at least 15 citations. Okay, so it means n number of papers having n number of citation in each of them. Okay, or h number of papers having h number of citation in each of them. Okay, that is very important. You should have h number of citation in each of them. For example, if I have published 10 papers, and out of the 10 papers, 9 papers are having 9 citation each, and the uh, the 10th paper is having 10 citation, then my H index will be 9, because now I have only 9 papers which have 9 citation indexes each. Okay, until and unless I get 10 citation on each of them, I cannot say that my H index is 10. Okay, so in this regard, you can see that the H index doesn't increase linearly. What I mean to say is that if suppose say you want to increase your H index from, if you want to improve your H index from 2 to 3, what you have to do, if suppose say you have already 2 papers, you need to publish one more paper, and in all the 3 papers that you have, you need to have 3 citations at least. But suppose say if you want to improve your H index from 44 to 45, you will have to publish one more paper. Suppose say you have already 44 papers because your H index is 44, but what you will need to have is that the fifth paper that you have, the 45th paper that you have, it must be published at the same time. All the 45 papers must now have 44 citations. So it means you need one citations on all the previous papers that you have published. At the same time, you need 45 citations on this final paper that you have published. So that is why we see that H index is not linear scale, and it becomes difficult to improve your H index as you go on higher and higher, because in H index you need both quality as well as quantity. In what I mean by this is that you need to have more number of publications. At the same time, you need to have more number of citations. Only then H-index will improve, right? Because if you have 10 papers, then each of these 10 papers must have 10 citations. If you have H-index of 20, then this all the 20 papers that you have must have 20 citations. Only then your H-index will be 20. Okay, we'll go on to the next topic. The next topic is on ABDC list. Again, ABDC list is something that is relevant to the people who are from management and the business sciences. So here what happens is that ABDC is not an indexing, but rather it is a list. Okay. For example, each year you know that for institutions, a NIRF list is published by the government of India. This NIRF list is just a ranking list. What it does is that it ranks all the colleges or the universities or the institutions in India, depending on 1 to suppose say 1 to 200 or 1 to 500. Similarly, in the ABDC list, what happens is that here all the journals that we have are listed and are given some kind of awards. Okay, these awards are made on the basis of, suppose say some are A star category, some are A category, some are B category, and some are C category. So depending on this, we have in the latest version, which was published in December 2019, we have 2,682 number of journals. Okay, and we have somewhere around 7.4% of them in the A star and remaining them in the ABC. Okay, so ABDC list is considered to be the most reputed list in terms of the management and the social in terms of the management and the business sciences. Again, ABDC list is a very exclusive list, so it is not an indexing, rather it is a list of the particular journals that are there in this in the field of management sciences. Priority journals are those kind of journals which try to dupe the researchers or which try to cheat the researchers by believing them that they are some quality journals, but in reality they are fake journals which just are after the money of the researchers. They take money from the researchers in terms of in the name of open access fees or article processing fees, and they publish this paper directly on the online mode or in the offline mode without any peer review. Okay, so at all times you should always avoid priority journals, because priority journals are not included in any quality metric. Okay, these are not included in the Web of Science database, and these are generally not included in the Scopus database, though time to time, because of some kind of issues, some of the priority journals find their way into the Scopus database, but as soon as it is reported to the Scopus, they are generally taken down from the Scopus database. So that is why what you should do is that you should not try to publish in the Scopus database. And how to identify, sorry, I'm extremely sorry. I said that you should not try to publish in Scopus database. I wanted to say that you should not publish in priority publishers. So that is why you did not publish in priority publishers, and you should not publish in priority publishers. And how do you identify which are the priority publishers? You identify them by the kind of site and the kind of indexings that they are in. If they are indexed in good indexings like the Scopus or the Web of Science, okay, then chances are that they are not predatory. But if you see some kind of indexings like and impact factors like global impact factor, site factor, or universal impact factor, these are all fake impact factors. So if they are listed in this kind of, if they are listing in their website this kind of impact factors, then you should totally avoid them, because these are fake journals. How do you avoid these journals? You can avoid these journals by referring to some of this list, this red color list that I have shown here. If a particular journal is included in any of this list, you should not publish in that. On the contrary, if some papers are listed in any of this, for example, in the SCI, SCIE database, SSCI database, Scopus database, ESCI database, or Web of Science database, or if it is mentioned in the Anna University of Annexure, or if it is mentioned in the UUC care list, then you can go for this particular journals. But you should at all times avoid the journals which are listed in these three websites. These are blacklist. This is a blacklist where the blacklisted journals are mentioned, so that people are not misguided and they do not publish in these journals. So at all times, you should avoid the journals that are listed in these three websites, but at the same time, you should try to publish in journals which are listed in these three categories that I've mentioned, whether it should be in the databases that are shown here, or it should be in the anonymity list, or it should be in the UGC cared list. This brings us to the end of this session. We'll continue our discussion on the UGC care list in the next session.